Okay, my name is Simon Mosley. I'm with Atlantic Fluid Technology. We represent Hydrogate, who supplied a couple cast iron sluice gates recently for Upper Blackstone. And the training today is going to be on cast iron slide gate, cast iron sluice gate. Hydrogate is located in Denver, Colorado. They have been around for a number of years, since back in the 40s. Started out in a lot of irrigation systems, and they're one of the leaders in cast iron sluice gates. And here you just have a vintage photo of some of their gates back in the 40s and 50s. Today, rather than just talk just about the gate that you have, I was going to run down through some of the gate lingo, sluice gates versus slide gates, the allowable leakage, types of seals or seats that are on these types of gates, what is a design head, operating head, the differences between the self-contained and a non-self-contained gate, some of the mountings of how these gates are installed, stem guides, some of the nomenclature of the various components of a cast iron gate, and then talk about some non-rising stems and dual stem gates. In years past, all cast iron gates were called sluice gates. In 2002, the AWWA changed their regulations and decided that they were going to be called slide gates. So now, technically, all cast iron gates are called cast iron slide gates. One of the things that did not change is leakage requirements. In years past, leakage requirements or leakage allowable was 0.1 gallons a minute per wetted foot perimeter of the in the seating head direction, and 0.2 gallons a minute per foot in the unseating head direction. And we'll talk about seating and unseating in a couple slides. But that is the leakage allowable. So if you have a 12-inch gate, that means that the perimeter is 4 feet, which means in the seating head direction, you're allowed up to 0.4 gallons a minute of leakage. In the unseating direction, you'll allow 0.8 gallons a minute. And that's just a 1 foot or 12-inch by 12-inch. On the flip side, stainless steel gates in 2002, they increased or improved their allowable so that their allowable is 0.1 gallons a minute in the seating and 0.1 in the unseating. In fact, some of the manufacturers, such as Whips, local manufacturer in Athol, Mass, typically goes to 0.05 or 0.25 in the shop. So you can see that some of the fabricated gates are going to be as tight or tighter than a cast iron gate now. And that, again, was a change that was made in 2002. Here's just a slide of the actual regulations calling out the allowable leakage for the cast iron gates. Cast iron gates, the way that they work or seal is they have a metal-to-metal seating, and you can see right here, here are the two seats. They're metal-to-metal, they're machined in the shop, and the way that they work is when the gate becomes fully closed, you have wedges on the sides, sometimes you have wedges on the top, force these two seats together, and that is causing the gate to seal properly. One of the things that comes up all the time with gates is what the heads are. Most gate manufacturers are looking at the center line of where the gate's coming in, so that's typically the center line of a pipe, up to the water level. And that can be your design head or your operating head. Your design head is what the gate is going to see, what the maximum head is going to see. So if you take an example in a tank that might be 20 feet deep, your design head has to be 20 feet. The operating head commonly is the same head, so it could still be that 20 feet, but there could be applications where you only want to move the gate when the tank only has 4 feet of head in it. So your operating head could be 4 feet, but your design head could be 20 feet. The operating head is going to control the size of your actuator. In this case, they're manual actuators, but also that would control it if it was an electric actuator. Your maximum operating load takes that operating head into consideration. It calculates what the load is that's going to exert, plus the weight of the gate, plus the friction that is working between the gate and the frame. We add all that up, and that's going to determine how much force is being needed to be exerted to lift or to lower this gate. Another thing that comes up is seating or unseating head. Very simple concept. Here you have a cast iron gate beside you wall. In the level on one side, it is in the seating, so this gate is in the seating head condition. You're trying to push that water, the water is trying to push the gate onto the wall. You have water on the back, no water on the front. So you have an unseating head condition. The water's trying to blow this gate off the wall. And this is why, if we go back to that leakage, you're allowed a little bit more leakage in an unseating head direction because you're trying to push the gate off the wall, as opposed to seating head condition where your water is working with you and you should have a tighter seal. A couple other terms that come up are self-contained and non-self-contained. Self-contained gate is one that is generally going to arrive on the job site, come off of a truck, and it's pretty much all ready to go. Most in-channel gates are going to be designed this way. So what you have is you have the gate down below here, you have a frame, you have a yoke assembly. This all comes in off the truck. The stem typically is installed, the actuator is typically installed. So what happens is the contractor is going to take it off the truck, lower it in, anchor it, install it with grout, whatever needs to be done, and he's done. Very straightforward. This particular one is showing a little manual hoist up at the top. So in real world, this is what they're going to look like. Again, most in-channel systems or in-channel gates are going to be looking this way. On the flip side, you've got non-self-contained gate. So here's a cast iron gate. It's on the wall. In this particular sketch, you have a floor. Another reason why you go with a non-contained gate is the distance from the floor down to the gate, maybe 20, 30, 40 feet. So there's no need to spend the money to have a frame go up 20 or 30 feet. So you just simply have the gate down below. May have some stem guides if they're necessary, and then you've got your manual hoist or electric hoist up top, and then you've got the stem. So from a contractor standpoint, he's installing the gate, then he's installing the other components, he's plumbing it up, he's putting in the stem. So there's a little bit more work involved for the contractor, but again, there are applications where this is the style you need because you're going through a floor, and that's in your case here for these gates, you're going through a floor, so you have a non-self-contained gate out here. On this sketch, just touch upon a couple things. You've got stem guides. The reason for you have stem guides is if you've got a long stem, you need to support it, and so you may have 1, 2, 3 multiple stem guides to support that stem as you're raising and lowering the gate. Again, you have a manual hoist with a crank on it. In this picture here, you can also see cast iron thimble. For most cast iron gates, you're going to have a thimble poured into the wall. This particular one is an F section, and we've got slides coming on in a few minutes to talk about the other types of thimbles. So here's a real world non-self-contained cast iron gate. There's actually 3 of them. Here's a fairly good sized one with a single stem guide. Smaller gate. This is more about the size of your gate that we have here. And in this particular case, you got a couple stem guides, and then again, you got your manual hoist up top. And here's one over here as well. As I said, most gates, cast iron gates, are mounted onto a thimble. So here's a real-world picture of what the thimble looks like. We've got a couple others of just the thimble. So the thimble is poured in place when their contractor is pouring the wall, and then the frame is bolted to the thimble. For a cast iron gate, they are cast. That means that there is a pattern, typically a wood pattern, that is used in the casting process. A couple things that you'll note is, in order to get some strength, you have a number of ribs. The more ribs, the deeper they are, the stronger the gate is. We've got a couple pictures of some pretty high head applications with a lot of ribs, big, deep ribs. Also here you can see your wedges. So you've got 4 wedges here. So this bottom wedge here is on the frame. That's going to mate with this bottom wedge here. This second one here is going to mate with this one, and so on. And this is the top one, and that's the top one. So they're really only going to engage when the gate moves down to this position. So they're really only engaging for a short distance of the travel right at the end, at the fully closed position. You've also got a thrust pocket. Here's a couple pictures of one. This is simply where the nut is connecting to the stem, and we call it the thrust pocket. So here's a couple different representations of that. So we're going to talk about cast iron gates today. Again, it's a cast product, so it's heavy machining, using a foundry, so the gate is cast, and then a lot of machining. Here you've got a couple typical gates. Here's a 10-foot by 10-foot cast iron gate. This has some serious head on it out in the Rocky Mountains. You can see by all of the ribs that are on here that you've probably got some serious operating heads on here or design heads on here. Thrust pocket up top and a number of wedges along the sides, and it looks like some wedges on the top. Here's another gate. Again, very serious ribs. A lot of operating head on this one. This particular one is a bullnose design, for the high flows or high heads that are going through it. Quite a few stem guides here. Deep gate, long stem. Some thimbles. You have a F-section thimble, you have an E-section thimble, or you have a mechanical joint thimble, simply used on the right application. Most thimbles are the F-section. You would use an MJ, mechanical joint connection, for one where you're connecting into a piece of pipe. How are they operated? This particular one is manual. You also can go electric or portable operator or hydraulically. This is very similar to your application. Again, you can go with a hand crank or hand wheel. One of these pictures, this picture here is actually, I think, up at Blackstone out of the distribution box with a hand wheel. And then this picture over here on the upper left is a hand crank. Electric actuators, that's available. This particular one doesn't have it. It has a manual hoist, but to run through it, electric actuators are going to be a little bit easier. You push the open or close button. They all have the ability to be operated if you lose power or the control goes out. Couple different types. Each manufacturer is a little bit different. but in general they're going to have controls and some kind of override available to it. In terms of maintenance, really two key things. One is to grease it and one is to exercise it. What we like to see is we like to see every 6 months or 100 cycles, depending on the frequency, is to grease the stem, grease the lift. For those that are manually operated, which I believe yours is here, and it's going to be an infrequent operation, we like to see it move every 6 months if possible, and we're just moving it a couple inches. That's in order to break any buildup between the two metal-to-metal seats. In terms of the products, certainly look in the O&M for specifics, but you have typical grease for the stem and then a typical grease for your lift. Again, it's really just a site-by-site requirement. The more you operate it, the more you're going to need to grease both items. And that's kind of the quick rundown. The only other thing is down below at the gate. It would really, if you can, every 6 months or so, it'd be go down to inspect it. But there really is nothing to do down below at the gate. And that is it for Hydrogate cast iron sluice gate. One of the couple questions that have come up in past training sessions, one was sort of a clarification on the lubrication and the grease for the stem. Depending on the operation, if you're moving the gate a lot, then the grease is going to be distributed and used up, and what you're really trying to do is keep the grease between the stem and the operating nut. And so for this application, you're only moving that gate very infrequently. So I would expect that you can probably extend out how often you grease that stem. However, there's some of the gates that are out here that you're going to be using more frequently. So you got to keep an eye on the grease on that stem. It doesn't take much just to grease up the stem periodically, and a couple telltale signs. If the stem is really shiny or looks like there's no grease, it probably isn't. If you hear a high-pitched grindy noise or high-pitched wear noise, then you need to add a little bit of grease. Those are two telltale signs. In terms of replacing the grease, it is recommended that every 6 months you pull all that grease off, clean it off, put on new grease. Part of that is just to put new grease on, but part of it is, especially the ones that are outside, they're going to get dirt, they're going to get dust. There are stem covers on the gate, on top of the stems, but the potential is that they could get some dirt and grease in there, or dirt and debris in there. Ones that are indoors are not going to be exposed to that, but again, it's always a good thing just to clean them off periodically and to put new grease on. Other than that, the only other question would be, what do you do down below? Again, periodically, it'd be nice to go down and inspect it, clean it up if you're down there, but there really is no